25 years ago, while I was studying landscape planning, here in the United States, I discovered a concept that fascinated me and that I have applied in all my projects and plans. This concept is the green infrastructure. It is such a simple concept. Place in one map all the most valuable landscapes and create a network of green spaces before growth. This concept was founded here in the United States by the fathers of landscape planning more than 100 years ago. A good example is the Emerald Necklace in Boston, where Olmsted designed a network of green spaces using the existing landscape infrastructure, rivers and healthy wetlands, floodplains, as a river park system from which the city of Boston expanded. I have incorporated green infrastructure into planning policy in the autonomous region of Valencia in Spain. Now, 550 municipalities are required by law to do the green infrastructure before they do the development plans. At the same time, I developed plans and projects at all scales to show people the benefits of doing green infrastructure. What I could not do, although I tried, was to offer maps and apps to help municipalities deliver their local green infrastructure. So when Jack invited me to take up this challenge with him and his team, I just dropped everything and came right away. The concept of creating a network of green spaces is now more important than ever. In a world where population has grown 4 times in the last century, fragmentation of the landscape has become the main threat to biodiversity and therefore to human life. Green infrastructure is a very simple idea. I'm going to show you in this example. It is not a question of whether communities should grow, but how and where to grow. In most cases, development is done first, while conservation of landscapes is an afterthought. Let's reverse the order. First, identifying the landscapes of greatest value and then growing. Place in one map the areas of greatest ecological value, then the ones with greatest cultural and visual value, and the ones most highly rated and loved by the population, as well as any hazard areas. Green connections are sought between these to preserve the functions of the landscape and make all the landscapes accessible. Connection is also ensured on an urban scale by creating linking and creating itineraries, linking squares, gardens, parks, main streets with the landscapes of the highest value in the surroundings. Everyone benefits. The new development benefits from a quality setting which keeps their landscape identity. We preserve areas of environmental value and biodiversity and avoid hazard areas. The term green infrastructure was created here in the United States and has been exported all over the world. Europe, Australia, China, South America, everybody is talking about it. The European Union is developing a strategy for green infrastructure to achieve common European policy objectives in regional development, water management, agriculture, forestry, environment, risk management, and climate change. Here in the United States, more and more green infrastructure projects have been carried out, and there is a wealth of experience demonstrating that the approach is flexible, sound, and cost-effective. Esri has helped many of these initiatives at the scale, regional, and local level, and has seen that they all share very similar goals and vision: to preserve lands and water on which life depends and to enhance the quality of life of our communities. But valuable landscapes don't stop at municipal or project boundaries. If no action is taken, we will only have independent initiatives that they don't deliver the full potential to restore ecosystem functions. So Jack thought, wouldn't it be wonderful if we could have a common national framework, maps, and tools that allows us all to have a complete picture of our environment before development occurs? We have now a green infrastructure framework, maps and apps, and guidance to help you define your local green infrastructure. This framework works at all scales. At regional scale, conserving ecosystem functions. At local scale, creating a green belt around towns and preventing urban sprawl. And at urban scale, connecting urban public spaces with the surrounding landscapes. When consistency and coherence is achieved across the different scales, benefits are multiplied manifold. What happens upstream will have an impact downstream. We now have, for the first time, a map of intact natural areas for all United States, from where you can zoom in and create your own green infrastructure. You can filter and rank these areas for their ability to support your local native species based on size, shape, extent of water, soil diversity, vegetation. Areas of ecological, cultural, visual, farming value, and critical areas like floodplains can be added to refine the model based on local priorities and goals. Decision makers, planners, investors, local people will know now that in the green areas they have some kind of environmental restrictions, and they just have to click at the GIS map to know which they are. As you can see, green infrastructure is about transparency. Everybody will know where the most valuable landscapes are before development occurs. Having all your most valuable landscapes in one map, rivers, tributaries, critical habitats, wetlands, floodplains, primary culture, and connecting them to the city allows decision makers to identify how proposed new projects and urban growth potentially impact on existing natural resources and how to mitigate and manage them. Green infrastructure is the harmonic confluence between environment, development, and economy. Water is the backbone of green infrastructure. Water needs a space to adapt to climate change, and we need to reserve that space. If, for example, you intersect the intact habitat area that Esri has created with rivers, you will visualize priorities and opportunities for connections, conservation, and recreation. You may add other important information and create river regional parks, connecting, for example, existing protected areas and linking national trails with towns and the sea. Where are the areas that should be protected? Where are the opportunities for land acquisition? By designing green infrastructure, we can preserve a space for water and enhance biodiversity, recreation, and local character, creating ecological corridors and making possible a new relationship between urban and rural areas. Growth is going to occur. If we don't design green infrastructure first, we will lose those areas and connections forever. Once connectivity is gone, it is much harder, if not impossible, to re-establish it. Why is green infrastructure so successful? Why are there so many countries around the world taking it on as the new conservation approach of the 21st century? Because it is very simple. Everybody understands it. Because it joins conservation with development. It saves money. Because you show people benefits that they understand and care about, like access to nature, beautiful landscapes in the surroundings, clean water and air, increase of property values. Because it is about transparency, and everybody and all disciplines feel involved. The time to do your green infrastructure is now. We have now the technology and information to deliver it at all scales. Thank you.
Thank you, Arantxa. I wanted to have Arantxa speak before I spoke about her, but wouldn't you agree she's an amazing geodesigner? I mean, really, she is amazing. She understands the method. She understands the technology. She understands the vision. she understands what must be done. So I'm so happy that you agreed to come over, leave your family, leave everything, and work with us on this project. We haven't told you much about this project yet, but this project is going to be released inside of ArcGIS Online and made available to all of you. The other partner, the key anchor on this project, is Hugh Keegan. Let's go over and take a look at what Hugh's doing. Come on, Hugh. Hugh Keegan. Hugh Keegan, I need to introduce you to, is yet another landscape architect. Okay, he's not a geographer, but he's a landscape architect.
Thank you,
And
Jack.
he also is a student of the very same professor that influenced Arantxa and myself, Carl Steinitz. So listen, ladies and gentlemen, what he's going to show you is similar to what Humboldt did, except doing it digitally.
I'm not sure it's that big.
He's a little embarrassed and very hard to get up in front of groups. Hugh, why don't you tell us what you're doing?
Thank you, Jack. Thanks, Arantxa. So when Jack came back from listening to Arantxa talk in Spain in October, he was terrifically excited. I mean, like he was like a little kid excited. And he came back and said, I've got this great idea, which struck terror into my heart, because what he wanted to do is he wanted to construct a national database which was applicable at all scales of planning, from the local level, could be supplemented with higher quality local data, but could be used at the landscape scale, the regional scale, the state scale, across the entire country. So we started working on this, and we were fishing around for, like, how the heck am I going to do this? I don't know anything about this. And we came across a methodology published by the Green Infrastructure Center that was written by Karen Firehawk and Andrew Walker. And remember Karen's name because she's going to be here the rest of the week, and she'll be happy to talk to you about the process. So basically, what did we do? We took the National Land Cover data set from 2011, so it's a little stale. It's going to be updated this year. We'll update our data to correspond with the update in the National Land Cover data set. And we said, get rid of anything that has the word developed in it, and also remove anything that says agriculture or pasture land or hayland. So agriculture is terrifically important for green infrastructure, don't get me wrong, but it's not habitat. So we need to be thinking about agriculture, but it's not habitat. And we're trying to identify areas that have intact natural areas, let's just call it that. So what does that look like? Here's the National Land Cover data set. And if I get rid of developed and ag land, this is what's left over. And it ends up being about 500,000 polygons, areas that are at least 100 acres in size and at least 200 meters wide. And you think, okay, well, that's a lot of these things. But 90% of these are less than 3,000 acres in size. And 50% of them are less than 500 acres in size. So that means that the responsibility for managing these areas are in the hands of private landholders, not in terms of national landholders. As Jack said, we're unlikely to get more national parks built or national forests created. So this is what it looks like at the national level. If I zoom into a local level, we tried to give you some context about what this might mean for your own watershed, your own county, your own state. Because remember, this is about making connections between your local community and communities around you. So here we go. So this gives you some sense of the density of these things. The other thing we did when we began exploring this data, we got these areas together, and then we started overlaying on top of them other types of data sets. And one of the things we came across was the number of endemic species, and this isn't all endemic species, but it's trees, birds, mammals, reptiles, amphibians, and freshwater fish. And if you look at this map, there's an awful lot happening in the southeast where Chris and Hobie were just talking about. And if we compare that to the protected lands in the United States, those lands that are managed exclusively for biodiversity protection, you can see we got a little bit of a mismatch, right? So we might want to do something about this. We might want to keep it in mind as we do development. So let me go back to that for just a second. So the other thing to look at this is, remember it was Chris showed you this incredible map of sugar maples being driven deep, deep, deep into New England? Think about what's going to happen to these endemic species. These only occur in North America. These are part of our natural history. So where are these things going to go, and who's going to help them get to where they need to be if we're going to preserve them, right? Right. Move up. So we have a climate change kind of story, but we also have a human change story as well. So we have some friends at Clark Labs. Ron Eastman sent me his forecast of what the National Land Cover Dataset will look like in 2050. And so you can look at this and say, according to Ron and Clark Labs, there's going to be an 18% increase in developed lands. And what I want to do is I want to go back down into the southeastern United States and take you down to an area in Harrison County. Look at the dark green areas. You zoom out a little bit here. Whoops, other zoom. Look at the dark green areas. This is forest lands and ag lands going someplace else. Remember I talked about how important agriculture is? We're going to have 70 million more US citizens in 2050. We need to be thinking about how we're going to preserve ag lands and our endemic species. So this is all part of green infrastructure planning. Yeah, you know, Jack, I actually sent Ron an email about this because I thought, hey, Ron, what's these hard line things? Yeah. And he sent me back a very polite note that basically said, hey, Hugh, you knucklehead, you might want to look at the base map below this. And that just turns out to be the DeSoto National Forest. Yeah. So it actually is a protected area, but it's all the areas around it that we're responsible for, private landholders and local communities. So the way the country is going to look is going to come down to local zoning boards, planning commissions, conservation groups working together to connect across the landscape. So we've tried to put together some tools to help people begin to think about how they're going to prioritize these areas that they're going to keep or try and keep and protect. So let's go back down into a kind of an interesting area. This is in the Piedmont, and after doing all these overlays, we have the ability to begin doing some selections or filtering. This particular part of the Piedmont is blessed with an incredible number of endemic species. So if I push this up, you'll see that I'll get a subset of polygons here. And the other data layer we're looking at here is Dave Theobald's human-modified landscapes. These measure both the footprint of human modification, but also the intensity of modification. I'm going to bring this down. So I'm not a planner, although I was trained as a landscape architect. But if I look at this, I'm kind of thinking the Savannah River might be an important area that we might want to try and hold on to into 2050 and beyond. Oh shoot, there's Augusta right in the middle of this. Maybe there's a mechanism by which we can reestablish a connection from Augusta back into the Piedmont and up the Appalachian spine.
Corridors.
Corridors. Exactly. So one of the things we've done here is that once you've done a filtering or a subset like this, you can store this in ArcGIS Online, and it's available across the entire platform. So it's available for analysis. You could bring it into GeoPlanner to do your design work. If you wanted to do viewshed visualization, you can bring it into ArcGIS Pro. We've created a website, Jack mentioned this, and one of the things, this is a work in progress. We're a little bit behind on it, but I wanted to show it to you. We have story maps about how to get started. We have recommended reading lists. There's a very nice little booklet by Arancha that you can look at, and she'll be signing this upstairs today. We also have a collection of tools, and we're going to be expanding these, including some of the ones that I've shown you today. But more importantly, there's also this Green Infrastructure Atlas. So this is part of the Living Atlas. And the idea behind this is local communities contribute their data. It can be added to support local planning exercises. So you can supplement the data we have with better, more authoritative local data and connect this across all scales. So it's all about prioritizing and connecting your landscapes.
So can you do weighted overlay sorts of things with your own data and this data?
Absolutely.
That's a prompting question.
Yes, of course. And we have an application. We'd be happy to share that to you. One of the things we didn't quite get done, we've done the analysis, but we're still in the middle of the QA process, is connectivity as part of this. So Jack talked about corridors. We have a new tool in 10.4, cost connectivity, which is very powerful, very fast. We haven't tried to run it across 555,680 polygons before, so we're still doing some QA on it. But this, I think, is going to be a powerful tool to help people try and quantify what the cost. They can generate their own cost service and quantify the expense of genes moving across the landscape, or species moving across the landscape, or can that salamander actually get to the adjacent watershed or not? So we can begin doing that. So I would very much like to invite you to come upstairs to the sail area and talk to Arancha this evening and Karen Firehawk. And we're going to have a special exhibit in the main lobby for the rest of the week. And Karen and Arancha will be there, and they'll be happy to answer questions and make suggestions about how to prioritize and connect your own green infrastructure in your own local communities. Thank you.
It's great. Nice. Thank you so much. Yeah, thank you. Look, we have had 100 discussions about this particular project over the last year. One of the visions initially was, why don't we just make a green infrastructure plan for the United States? Doesn't that make sense?
Only if you're Gifford Pinchot.
Only if you're or if you're a gifted person. The complications of building plans require community involvement. They require collaboration. They require looking differently at different locations uniquely. It involves involvement. So what Hugh and his team have built is basically all the data sets. They've integrated these data sets into a handful of applications that you can use, including ArcGIS, of course. The idea is not to build a plan, we're simply going to provide you this as a gift, and I mean that in the most sincere way, as a gift for all of our users to grab onto this resource and begin to introduce this kind of green infrastructure planning in your organizations. I think it will be impactful. It's not a plan, it's a series of methods and a series of tools that you will craft your own plans with. And sorry, go ahead, Hugh.
I forgot to mention that we've actually organized all the source data that we use to do this analysis as downloadable data.
Yes.
You can get to it. So
it's open data.
It's open data. So we've collected all the open source, all the federal sources, gotten permission from Dave and from Clinton Jenkins at biodiversitymapping.org to use this data, and it's available for local communities to use.
So thank you, Hugh, and thank you, Arancha.
Thank you.
Thanks, John.
What a team.